Incidentally, whilst we have the galaxy here, I should mention that the galaxy has certain structure. It's not just a solid ball or disk of stars. If you looked at that slide on, it would look like this. The sun is out here. We're pretty close to the edge. That's 10,000 light years across. But again, that's just useless. I mean, can anyone here imagine the size of a light year? There's a central bulge, which is probably the most interesting feature. Most of the stars, most of the mass is right in the center of the galaxy. There's also, we believe, a black hole at the very center, which has the mass of about 3 million suns, but it'll stay there, so don't worry about it. The next closest galaxy is Andromeda. Let's just see how we're doing here. Andromeda, let's just get this one. If you could see this, and it's too faint for human, just for your eyes to see, the center here would be about the size of the moon on the sky. That's how big it would look on the sky. In terms of how big it is, it's about the same size as the Milky Way. How far away it is, that one's easier than the last step we just did with the hairs. If I had the Milky Way in the palm of my hand on this side, Andromeda would be over there. So that's how far away it is. I don't want to alarm everyone, but it's also coming straight for us at about 300 kilometers a second. The good news is, on this scale, 300 kilometers a second is actually about half a millimeter every million years. So, don't be alarmed, go about your lives. Actually, even when it gets here, it's not a bad story at all. Collisions between galaxies look, if we can't actually do this in real time, so this is a simulation, but we hope that they look something like this. Keep your eye on the center of them as they collide. The local group of galaxies, so that's presumably what, well, to the best of our knowledge, what will happen when Andromeda gets here in about 3 billion years' time, so don't worry about it. What will probably happen, it's going to start again. You notice the outsides of the galaxies got sort of flung out of the collision, just thrown clear. We're in the outside of the galaxy. What will probably happen is that the solar system as a whole just gets thrown clear of the collision and gets a ringside seat to watch the second half. It's really quite cool. There's a fantastically small probability that anything significant will happen to the solar system. So as the galaxies come together, it's not the stars that collide. The gas in the galaxies does collide, but the stars, by and large, just pass straight through each other. It's really not that big a deal. Because of gravity, their paths change as they swirl past each other. But other than that, stars and solar systems just go through the collision out the other side. Now, the local group of galaxies aren't just spread uniformly throughout the universe. They come in groups. So remember I had the Milky Way in this hand and then Andromeda was in this hand. Our local group is just a little bit bigger on each side, maybe sort of 2 hand spans. It's a little bit, I think it's slightly bigger than our paper mache Earth that we had here. In that side, there's another 35 galaxies, but most of them are quite small. So Andromeda is big. Andromeda is big, the Milky Way is big, the rest of them are called dwarf galaxies and they're quite small. On bigger scales, groups of galaxies get together into groups of groups, which are known as, or clusters of clusters, called superclusters. So this is nearby superclusters. Now, if I have the Milky Way in my hand, we're part of what's called the Virgo supercluster. It's about the size of half a football pitch, where there are just groups of galaxies. Remember our local group? There's just more of those just spread throughout our supercluster. Now, you might be wondering, are there superclusters? Do superclusters get together and group together? So far as we know, no. That's the end of the story. These are the superclusters in our. We're at the middle, the Virgo supercluster. These are the superclusters in our neighbourhood. And so far as we know, it's just kind of, there's a supercluster, there's a place where there's not a supercluster, which is about the same size, and the whole thing just patterns all the way through the universe like that. So we've reached the limit of what you can call sort of a thing, a gravitationally bound thing with superclusters. So there's one more level we have to go, so let's finish this thing off. Remember the observable universe at the start? This is the first that we can possibly see. So let's have a go at that. Stick the Milky Way galaxy on your thumbnail. You should all be used to this sort of thing by now. I mean, you've drawn the orbit of Neptune on a hair. This should be easy. Yes? Andromeda will be about a hand's breadth away and about the same size. Our local group of galaxies is about a foot in diameter, and there's about 35 more galaxies in there. Our supercluster is about the width of this room. The observable universe, the furthest we can possibly see into the universe. You remember Cambridge? There it is. And we've reached the end. We've made it to the observable universe. So, let's recap, shall we?